Morning teachers, we are Group 4 and today we'll be explaining how airbags work in a car during a car crash. Firstly, airbags are designed to reduce head and neck injuries during a forward movement in a crash, and it is important that the airbag inflates quickly at 15 milliseconds to prevent injuries. Airbags inflate mostly due to the nitrogen gas that fills it up. Firstly, there is a gas generator behind the steering wheel consisting of solid sodium azide, silicon dioxide, and potassium nitrate, which are crucial for the reaction. When the car crash occurs, the impact from the crash generates an electric current that ignites the gas generator. This leads to chemical reactions that lead to the production of nitrogen gas, filling the bag up. So what exactly are these reactions? Let's find out now.
Now, we will be talking about the three types of chemical reactions that take place when an airbag gets inflated. The first reaction is the decomposition of sodium azide. The chemical equation is as follows. Sodium azide has a giant ionic lattice structure, so it has a high melting point. When there is no heat supplied by the electrical circuit, the strong electrostatic forces of attraction between Na plus and Na- cannot be overcome and form nitrogen gas for the airbag to inflate. However, when the electrical circuit supplies heat, the strong electrostatic forces of attraction are overcome and nitrogen gas is released. This nitrogen gas then fills up the bag and cushions the driver to reduce injury. However, sodium is very active as it is a group 1 metal and reacts easily by losing one valence electron. Like other group 1 metals, sodium is so reactive that they are rarely found alone in nature. Thus, pure sodium solid is very reactive and can react with water vapor in the air.
To remove the pure sodium metal, there are thus two more chemical reactions to convert sodium to harmless alkaline silicate. The second reaction is an exothermic reaction. The chemical equation is as follows. Sodium loses electrons to form sodium ions. The nitrite ions react quickly to form nitrogen gas as the triple bond in nitrogen gas is very strong. Oxide ion then reacts with two sodium atoms to form sodium oxide, while two potassium ions then react with one oxide ion to form potassium oxide. Sodium oxide has a giant ionic lattice structure as seen here. Potassium oxide also has a giant ionic lattice structure. This is an exothermic reaction as the amount of energy taken in to break the bonds in 10 moles of sodium and 2 moles of potassium nitrate is less than the energy given out to form bonds in 1 mole of potassium oxide, 5 moles of sodium oxide, and 1 mole of nitrogen gas. Hence, thermal energy is released in this reaction. Sodium oxide and potassium oxide, however, are still highly reactive substances. Hence, to ensure that the airbags are 100% safe, there is a final reaction.
The last reaction is an acid-base reaction, which is the reaction between K2O and SiO2 and Na2O and SiO2 which takes place simultaneously. The end product is alkaline silicates. Silicon dioxide has a giant covalent structure and also an acidic oxide, while potassium oxide is an ionic substance and also a basic oxide. Hence, both substances will react in an acid-base reaction to form a potassium silicate. Next, silicon dioxide reacts with sodium oxide, which is both an ionic substance and a basic oxide. Hence, both substances react in an acid-base reaction to form sodium silicate. This is the structure of the end result of potassium and sodium silicate, which are both alkaline silicates. They are thermally stable, which makes them a safe end product. After all, you do not want to survive a car crash but end up dying from chemical burns, right? Thank you for your time.